Anyway, so that's me. Actually, this is me. I'm very X, except that I'm not yet an ex-human being, at least I hope. Interesting that Jez is doing things with law and expert witness. We're in a law firm. That's just so cool. Gratuitous picture of a squirrel because you have to. Anyway, what is MythTV? Well, it was originally when this guy Michael Lamoth in Australia, so I have no idea how you actually pronounce his name. Late 2000s, he was in there creating television software for your PC, writing it in C, obviously, because it's the one true programming language. And using Xine and VLC. I don't know if anybody's come across Xine or VLC at all. They're basically the same thing. And the idea is that you have a... Ooh, what happened there? That wasn't supposed to happen. That was supposed to happen. You have a blob, which is either Xine or VLC doing the rendering. And you have your code, which chucks in a whole load of bits and pieces. And you put your screen connected in there. That's the sort of basic architecture of what's going on with all of these television systems. What's coming in here then is the signal from the aerial. And if you do this on Windows, you get lots and lots of proprietary software you pay vast amounts of money for. If you're doing it on macOS, you can't. And if you're doing it on Linux, all of the decoding software is in the kernel. And the reason for that is because all televisions run Linux. And so therefore, all televisions have to have the decoding software in it. And it's all written by Samsung and Red Hat and so people like that. And it's crucially important stuff. So the bit down here is fundamentally Linux. Over here you've got either VLC or Xine in the history of these things. And there were a whole load of other ones, but those were the ones that Michael had chosen. He then started liking C++. I guess if you've been doing C long enough, you move on. And in particular, he actually wrote what was really quite a nice C++ 98 binding to SQLite. And if he'd issued it, he'd have been playing in the game, but he kept it within MythTV. And of course, C++11 comes along and changes the whole game of how you write C++ bindings to things. And so that became a bit of a non-starter as well. There is a reason for mentioning that as we go along. Version 1.3.7 was the last one in the series, 1.3. He then went on to build version 2. Why? Because you want to go full client server. Two reasons: because you have to, because it's client and a server, and that's just never mind. But what he wanted was a permanently running server so that he could do timing. I want to record a show at 20:32 on the 17th of November, and unless you've got a permanently running thing or some connection with cron, you're not going to be able to do it. So he went for the full client server thing, and then for some reason just gave up and just disappeared, as it were, from the entire project. And it was a single person project, effectively. He was the sole developer. And yet he had quite an audience of people using this stuff. And so what happened was a few of them clubbed together and got sufficient of version 2 and version 1.3 melded together so that they could actually get something working. By which time, of course, MythTV and Kodi had taken the entire business. If ever you've used either of MythTV or Kodi, they basically turn your small PC into a media center for your house. And they are very good at it. So there really is no point in competing in that market, because a single person project is going to go nowhere compared to these two products, and they are products now that have quite a lot of people contributing to them. And they're free and open source software. You don't pay for them, except on Windows, I guess. We have to pay for everything. So how do MythTV and me come together? Indian Premier League, basically. Okay, so you're sitting here at your workstation, and what you want is the television just there, so that you can carry on working and watch the Indian Premier League at the same time. This is crucially important that you have a second computer, because if you do picture-in-picture on your main computer and your boss walks past, you've got a real problem. In my, I work in the bay window, so it's working at home type thing, and the television's over there, right, which is singularly useless if you're looking that way, trying to work, and you want to. And so that was the primary driver for me getting interested in any of this. And of course, then there's the Autumn Internationals, and which are happening now. But then they used to be actually quite focused rather than all over the world. And the Six Nations, which is probably the second most important competition in the universe. Now, the Debian packaging was there, 1.3.7. Debian, Ubuntu, Mint, you name it, it's always there. But it didn't work properly. Tried to negotiate with the person managing the package, but they disappeared as much as Michael had from the entire project. The 2.0.0 was in a deathly state. Michael had just given up and gone. The 1.4 was working for some people, but it never got packaged into Debian. So 1.3.7 was the last that was in Debian, and it got pulled some years ago. It had been pulled from Fedora even sooner. And so there I was, compiling 1.3.7 to make anything work. So you're already at the coalface with the source code to make the damn thing work. But then there's some problems. The first one is, why the hell are we doing this at all? Because, well, okay, it was like 7, 8 years ago when streaming wasn't quite as good as it is now. And I've got a 40 gigabyte per month cap on my internet. And video takes a lot of internet. And you're thinking, oh, why don't you just change supplier? Well, 8 years ago, I was on a business line because I wanted a fixed IP. And so you couldn't get any of these unlimited systems. You had to have a cap. Fortunately, my cap is 8 to 8. So in between 8 and 12, I can take the entire internet, and everybody else has to just suffer because I'm on a business line. Yes! These days, you can get fixed IP, unlimited, and yes, I am beginning to shift. But Freeview is still fun, so I shall be doing this project anyway. Big downside, MythTV used GTK+2. Now, I'm not going to go into the warfare about GTK+2 and GTK+3. 3 is bigger than 2, it's therefore better. So there's just no contest. It's like GNOME 3 is better than GNOME 2, so just get on with it. Or, as some people did, just go somewhere else, just go away and let the GNOME people get on with GNOME. GNOME has its problems, but let's not worry too much about that. A really important thing here is that the DVB standard, and there is a huge standard, it's about yay thick in A4 paper. The version 3, the way of specifying transmitter files and the way of specifying channel files, was gratuitously awful. It was basically colon-separated variables of a fixed format with fixed values in the columns, which doesn't allow you to expand stuff. In the meantime, DVB had added T2 as well as T.
Sorry, DVB is the...
Digital Video Broadcasting.
Right, so this is the over-the-air signal?
Yeah,
Right.
yeah. And it has enormous standards, and Freeview is just a realisation of the DVB in the T format. There's also DVB-C for cable, DVB-S, and ASTC or something for Americans who refuse to use the same standard as anybody else. But the version 3 format for the files that contained the information was rubbish. And so there was this huge V3 to V5. I have no idea where V4 went. But V5 is actually sensible. They're sort of INI style files, key value pairs in paragraphs where the paragraph has a title. We can have a look at an example in a minute. But it's a much better format. Sadly, oh well, Xine becomes dead. I wasn't expecting that one. But anyway, I was using Xine, not VLC, because VLC never worked properly for me, one way or another, and Xine was working. Xine becomes a dead project. Do I want to pick up a dead project? I'm picking up a dead project. Do I want to pick up 2 dead projects? No. So Xine was very much going down. It was being unpackaged in the same way that MythTV was. And 1 or 2 people have nodded when they said VLC, I've used it. It is almost impossible to get into it unless you're already into it, because the documentation for VLC assumes you understand VLC.
You mean as a program?
As a programmer. You have to understand it before you can even read the documentation. It's impenetrable. Or maybe I was just biased. Mostly because I'm sitting on GNOME, and GNOME emphasises GStreamer anyway. So Xine's going by the by. We need something new. Do we get into VLC? I tried it a bit. No, I'm not going there, because one of the big things about the Xine system is it assumes you're using process with a socket. And I don't want to do process with a socket. I just want the one process. I don't want multiple processes flying around in sockets. Ooh. And GNOME emphasises GStreamer anyway. It's core to all of the audio-video stuff that's going on. And surprise, surprise, it's in most people's televisions, because Samsung, Sony and everybody else use GStreamer to handle a lot of their audio-video in the televisions. What is GStreamer? It's basically just an AV processing system that creates pipelines. So you have some input signal, you have a source that will deal with that signal. It then passes it on to one or more processing elements. This could be AAC, this could be MP3 or MPEG-2. And then you could carry on pipelining all of this stuff. And at the end, you have some sync or other. And if you're working on a workstation, you're looking for some sort of GTK sync or a QT sync or something like that. And that's really what GStreamer is, a pipelining system for signal processing. And it had a DVB source element. Well, that's good, that's great, that's work done. It does all the talking to the Linux DVB API, so you don't have to do any of that. But sadly, it thought V3 was a good file format. No, it's not going to be a good file format. So I thought, well, why don't I do a project to rewrite the DVB source using version 5? And there's a libdvb v5 library, the middleware, if you like, to talk from the Linux API up to sensible applications programming without doing system calls. Because, well, you know, you saw earlier, I've done a lot of Unix in my time, so I'm not averse to system calls. But as an applications program, I just don't want to go there. I want a middleware layer. And spontaneously, one of the Samsung guys who was involved in DVB Source popped up and said, oh, we had this patch from like 17 years ago to do V3 to V5, so we'll just stick it in. Well, that was the end of that project. What's the point in having an extra dependency if someone's just gone and fixed the thing in the first place? So that's cool. DVB Source now does DVB V5 format files. So you can actually get high definition signals now, which is extra cool. So I thought, back to the original. Let's rewrite this program that was going to be a personal video recorder and video player, but let's just do it as a player. So let's do the GTK 2 to 3 thing. Let's do the Xine to GStreamer thing. And let's just carry on with C++ because it's mostly in C and C++ anyway, and we're already doing a lot of changes. So why not just evolve the code base rather than start again? Well, that's actually a big question. Remember SQLite? It had a whole load of other stuff. It was a mixed C, C++ code base. There was an enormous amount of it. How do you change just the GTK2 to GTK3 without actually delving into, well, that's crap C, let's fix that. That's appalling C++ 98, let's move it to... And you end up rewriting so much of it. You think, no, let's stop trying to evolve this. Let's use it as a backdrop and pull out code if we want it into a brand new rewrite. So I started with a GTK3 rewrite, and it turns out to be a quite sensible thing to do because there's a lot of good stuff in GTK3 to do with having one and only one program that controls it all, a uniqueness thing. In GTK2, that's a separate library. In GTK3, the uniqueness library is an integral part of GTK3. And that's really very helpful. So I went for a rewrite, which means you can scrap a whole load of the old architectural stuff that was there. A lot of internal APIs, just get rid of them because GTK and GStreamer can already talk to each other. They can use the same event loop. That turns out to be really, really important to get rid of the sockets because the whole MythTV and Xine's system and the MythTV or VLC system was all about they couldn't share an event loop. You had to have two distinct event loops, and so you made them talk with a socket. We don't have to do that. GTK Plus and GStreamer can use the same event loop. Love it. Great help. What do I mean by devices down here? Well, here is my television. That's the whole point. Some people have PCI X cards or PCIe cards. Me, I just have USB sticks. They're cheaper and more portable. Let's not worry about databases for the moment, because if we're only going to be a player, we don't need to record stuff. So this was the backdrop to the C++ GTK-MM, GStreamer MM. Underneath, GTK is a C program. GStreamer is a C library. And they've got these C++ bindings that are handcrafted. So every time there's a change in the underlying library, you have to wait for the handcrafted API to change in order to be able to do anything. Oh, this is tedious. And then look at this. They went from 0.1 to 1.0. And the GTK-MM, that moved pretty quickly, and Fedora and Debian both took up the change very quickly. GStreamer MM, yeah, that moved on Debian, and they still haven't got it on Fedora. Oh well. I'll just leave that one. So we've had C++ 11 introduced threads, C++ 14 updated threads, C++ 17 has introduced all the parallelism stuff, C++ 20 will probably introduce metaclasses. They can't even strip strings with a standard library. And they have no thread-safe queue in the standard library. This is just insane. The one thing that Go has taught us, I think, which we've known probably for about 35 years, it's just that shared memory multi-threading seems to have taken people by storm, is that you send messages between processes, lightweight processes. What you don't do is handle all of your messaging with shared memory and mutexes, because that's just an insane way of managing internally the structure of your code. So the fact that C++ has no thread-safe queue as standard means that C++ is unfit for purpose. Okay, single-threaded programs, maybe. As soon as you introduce threads, C++ is unfit for purpose. Sorry, do you want to?
I just said, is that the only reason?
No, but it'll do for now. So I thought rewrite in D. Okay, because D is cool. Andrei Alexandrescu. Sorry?
D is bigger than C.
Yeah, absolutely, yeah. Alexei Alexandrescu. Oh, I'll get his name right in a minute. I need more alcohol. Jump ship from C++ to D. So that means that D must be good, because he wrote one of the standard C++ texts. Walter Bright wrote all of the C and C++ compilers in the 1980s. So he knows a few things about compilation and how to create nice programming languages. But we could have an entire 2-hour session on the history of D and only scratch the surface. It's a long, interesting, and sometimes violent history, but we don't want to get into the violence.
Where's it being used commercially?
Facebook, Sociomantec. There's a page. There's not that many, but yes, that's very true. Google do some D. It's not gained traction in the way that Go and Rust have, which is sad, because I actually quite like D. I think it's quite a nice language. No more header files and code files, so .cpp and .hpp replicate large amounts of data. That's got rid of. Maybe in C++ 306 they might eventually get modules. But the downside, obviously, is that there isn't a great IDE, but it's a work in progress. Sadly, it's a work in progress by volunteers, so it takes a while, whereas Go and Rust have been sort of grabbed by the scruff of the JetBrains neck and been turned into commercial IDEs already. Anyway, and anyone who mentions Vim will be culled. But mostly, this is it. This is a crucial thing in terms of bindings and APIs for doing these sort of projects. C code. You generate XML files that specify the API. From those XML files, you can generate any binding. And GTKD does exactly that. It's an automated system with a little bit of manual tinkering on the edge that allows you to create a debinding for GTK and for GStreamer, just like that. Not like that, like that. And this is a biggie. Because actually decoding the system is quite simple for MythTV, because you take the signal from the aerial, whichever way up it's supposed to be, and you shove it into a thing called a play bin. And the play bin in GStreamer says, oh, what sort of signal are you? Oh, you look like an MPEG-4, MPEG-3, 2. MPEG-2, which is the audio-video standard that DVB is based on. I will create a pipeline for you. So it detects the incoming signal and just creates the pipeline. What's not to love about this? Unfortunately, there is one item of information that's not in that stream, and it's not in the transmitter data. So the local transmitter, Talco, whatever it's called, is a sort of 100 kilowatt aerial, and we still can't get a signal in here, which is a bit sad. Just down the road there's a 7 watt aerial we can almost get a signal from. And the transmitter files transmit on multiplexes, so there's only about 7 actual physical channels going out there, and on those multiplexes are the 150 odd channels that you think of. And you have to scan the multiplexes to get the channels. And you can get the name of the channel, but you can't get the number of the channel. So none of that data tells you that BBC 1 is channel 1 and that channel 4 is 4, because that's part of the electronic program guide. It's not part of the audio video stream. Yeah, I don't know how that one worked. You have to get the electronic program guide in order to know that Dave is channel 12. Okay, so there I was writing away in D. I can show a bit of code later if we'll have a few minutes for a bit of code. I was happy, well, insofar as trying to work with some of the members of the D community, it makes one happy. And we had some nice progress, and we had things working, and that was cool. The GStreamer community rejected C++ because it was too complicated and just unworkable. And also, it has to be said, the GTK-MM people weren't using the GR files. And the GStreamer MM people weren't using the GR files. And that acted as a factor. So it's not a technical thing, it was a sort of socio-political thing that determined that C++ was unacceptable to the GStreamer community. C was the one true way. Go, garbage collector. Can't have a garbage collector, this is signal processing. D, it's got a garbage collector, this is signal processing. The fact that you can rip the garbage collector out of D and use it without didn't sort of break any ice with them. Rust comes along and they like it because no GC, it's as fast as C, and it's got despite being invented in C++, resource acquisition is initialization is really crucial to making code really nice, particularly when you've got an open and a close. You've got a stream, you want to open it, you've got to close it. Anything that got an open and close, and if you look at the G-object system in C, you get all these allocations and you've got to have a consequent deallocation. Manually, because it's C. But we're hard, so we can do that. Wrong. You want RAII, because it's the fastest way of avoiding memory failures. So C++ invented something interesting, but other languages have done it better. And in particular, Rust, by emphasizing move semantics and actually having a borrow checker. So the compiler checks your use of memory, and it checks absolutely everything it can about the safe language. There is also an unsafe language, which most people are told to avoid quite correctly, where you can do naughty things. But in the safe language of Rust, you can be pretty sure that you won't get any memory leaks. And that's a really nice guarantee. As I say, it's not total because there is an unsafe language. So what did Russel do? Yeah, bit the bullet, rewrite in Rust. It turns out to be not that bad. We'll see some code. GTKRS, really quite nice, generated from the GR files. GStreamer RS, generated from the GR files. So really nice representation at the binding level of the underlying API. Progress has been excellent. Actually, what we probably should do is a little bit of demo by now. Yeah, I've got a few minutes. So, whoops. Oh, I'll put them up here. You'll have to excuse the orange specks. One or two people already know they're protection against the devil of headaches and migraines and things. And these lights are hideous for anyone who has any sensitivity to light. However, enough of that. So here we have some D. Is it actually visible at all?
I can see it. Yeah.
Cool. Oh, seriously, though, is it actually big enough?
Yeah.
Okay, cool. As you can see, you do lots of importing of things because the idiom is to be explicit rather than implicit. So you avoid all this star import type rubbish. And we're saying that we want all of these things to be able to use them. And this is the UI type stuff. And anyone who's done any form of UI, even if you haven't done GTK, you'll recognize the sorts of things that are going on here. Buttons, combo boxes, header bars, images, usual standard GUI stuff going on. The application window is the one and only one. That's where the uniqueness comes in. And that was brought in between GTK2 and GTK3. So everybody's primary window should be an application window to guarantee the uniqueness of the application. And you know, it's like C++ in that you've got classes, you've got inheritance, all of that sort of good stuff. But it's trimmed down a lot, so you don't have quite as much baggage associated with it. Pardon? You can indeed hang yourself, yes. Because D, like C++, doesn't have memory checkers in the compiler because classes are reference types, so they're on the heap, and it chooses not to check those. So you can actually get lots of memory problems in D. It's not safe in the same way that Rust is. And you go on with the usual sort of, we've got to create callbacks. It just makes it nice. I mean, C++ now has lambdas and a hideous syntax that goes with it, but the feature is there and you can use it. D's had it for quite a long while, called delegates, just so it confuses anybody who knows C#, because delegates aren't quite the same thing in C# as they are in D. And so delegate's just a closure over the captured variables. So it's a function with a binding for all the captured values, usual sort of stuff. And so we create callbacks, add on activate, add on this, add on that. It's very standard GUI programming. But you've only got one file per group of classes because there's no header files and code files. It's all in nice little modules. The actual main function looks, code is code in some ways. You have to get into it for a while to really appreciate. But the names of the functions in D to do stuff with GTK and GStreamer, you can nigh on 100% infer from the C function name. So there's an affordance there between the underlying C library and the D binding, because the binding is generated directly from the C through the XML files. That makes it really quite interesting to work with. However, the problem is that we are forced to use Rust because the GStreamer people have gone with Rust. So here we've got the same two files, really. And there they seem to like these all-encompassing includes. Fairly standard idiom in Rust is to say, oh, give me the entire prelude for that particular module. It's very Haskell-like in that sense. It wouldn't surprise me at all if they'd nicked the whole prelude idea from Haskell. But there we go. I suppose the really interesting thing in Rust is that there are no classes, there is no inheritance. They just threw that out the window. Structures and methods associated with the structures. And in that sense, it's very much the same as Go. So you have data and you have functions, you don't mix them up, except to say that, and down here we've got, in these functions in here are the methods associated with that particular structure. Changes the way you think about code, moving from class-based language to a struct and methods-based language. I don't know, Dom, if you've had that from C++ to Go. Java to Go. It's a real mindset shift that you have to go through. You can achieve everything the same, but you just have to have a different approach to it. And everything is about how do you lay out your data structures, much more than it is with a class-based system as in C++ and Java. But you get the same sort of stuff going on here for methods. There's one. I guess they nicked it all from Ruby with vertical bars and stuff like that. So the vertical bars are going to be a closure over some code. So you capture, again, the values. But here, it's all about move semantics. So when you capture, you really do capture the variable. And so it's no longer available after the move. And so in particular, if in here we captured any of the variables from out, oh yes we do, look, we want access to the application. And so we have to actually make a clone of it so that it gets moved into the function that's there. And that's a crucial part of the ability to trace memory. So it's very explicit. It can be really annoying. And some people write macros. Now, in Rust, macros are not a dirty word because macros are checked at compile time. They are fully checked. Nothing like this C preprocessor rubbish, which is just string matching. Macros are actually quite useful. However, you should wait at least a year between beginning to learn Rust and attempting to write a macro. Now, I've been doing Rust now for about 14 months. I wrote my first macro last week. And it was about the right time to do it. Okay, so that's a little bit of code. What does this thing actually do? Well, unfortunately, I haven't been able to create the table that's needed because I can't get any signal. So although when it starts up it does that, and you then plug this thing in, and after a while it sort of decides that, oh, actually you've got two televisions in there because this is actually a two-tuner one. Most of them only have one, but I thought, oh, I'll splash out an extra £5 and get 2. And it's actually listing, I think this is probably, where are we? BBC One London, so this is actually my stuff from Crystal Palace. So this is the Crystal Palace channel list. Except that it hasn't got BBC News HD, which is a bit annoying. Don't know why. And you would probably be able to play some stuff, and it would look nice, and it would just be television. If I take this out, it sort of recognises it's gone away. I quite like that. Now, you remember I said the devices box? I wanted the devices to be a completely separate thing from the actual GTK playing. Keep things separate, small things doing and communicating with each other. And it turns out that this actually turns out to be one of, let me pause a moment. There are no MPEG-TS bindings in GStreamer RS, which is really annoying. They were there in D, but they weren't there in the GStreamer Rust bindings. But GStreamer had gone with Rust. It says, yeah, but we're doing all this other stuff. We haven't got time to do that. So Muggins volunteered, and yes, I will get some more stuff into the GStreamer plugins so that MPEG-TS is properly handled. Actually, I've been programming in C. It's hard work, it really is. Anyway, they're in because I couldn't face hacking the GStreamer RS to make it work. GIR files, we want the GIR files to get it correct. So go to the original source, fix it down there, the GIR files are correct, therefore the binding will be correct. So that was me just putting money where mouth is and doing the job to do it properly. And that commit will happen tomorrow when I compress the commit list into a single. Oh. Yeah, well, okay, the thing is that GitLab, the GitLab instance that these folks are using, doesn't understand how to do a squash merge. It's actually an official bug report. Okay, so just rounding off. If you were to pin me against the wall and refuse to give me any alcohol until I'd given an answer, I would say that I actually slightly prefer D to Rust. Rust has got this functional approach with option and result, and it's all very good. But at the end of the day, D's a little bit more lightweight for doing these top-level applications. But given that the GStreamer community are backing Rust, I'm going to go with Rust, and I will drop the D code. It's pragmatism, really, because the binding that's going to get the most effort is going to be the Rust one. I am never going to program C++ ever again unless someone pays me about £2,000 a minute.
Wait till March, that might be affordable.
Yeah. But in terms of bringing 1960s parallelism and concurrency back into 2019, or at least 2018, Rust, the GStreamer RS and GTK RS have done something really quite fabulous with trying to support asynchronous programming in terms of the event loop of these things. And this code exemplifies that. This is really at the heart of the idea of having the devices. Whoa, sorry, I should have pressed that again. Remember, I had the GTK box and the GStreamer box and the devices box. I want the devices box to be able to send messages when a new device comes on the stream or when one goes off stream. You saw that it did respond. So the devices monitor is just a notify event loop of its own. It's just a blocked thread just sitting there waiting for something to happen on the file store, checking /dev/dvb. And it then sends a message to the event loop. And so what we've got is a channel, and we just say, every time you get a new feature on this channel, run this code. And you've changed thread. So you're now executing the code on the GTK event loop thread that should be run on the GTK event loop thread, having sent a message from another thread. No explicit mutexes, no faffing around. If you ever try and do this in GTK-MM, you will go insane. I don't know how they carry on doing it. Anyone who's done any RX extensions in Java or Ruby or C# or stuff like that will recognize the backdrop to this, because it's all about sort of observables and trying to make the code appear sequential linear code, when in fact what you're doing is using futures and message passing just to make it easy. So I've just got a simple loop that means every time I get a future, do something on a different thread. And here we've got an example of an enum. Yes, they're enums that can carry values. Rust enums are really cool. They are very, very cool. So message front end appeared is one item in the enum, front end disappeared, one item in the enum, and the FEI is the identifier for the device and the front end that appeared or disappeared. And for me, that code, well, yeah, you're going to ask, what does that mean? Yes, good question. Let's not worry about that. And why do we have to do that? Yeah, good question. Let's not worry about that. Those things are likely to change because it's not a great bit of API. But the fact that we're saying, okay, give me the main loop, start an executor on that main loop, and every time the main loop goes round into an idle, it checks, oh, executor, have you got any work to do? And you've created this wonderful abstraction for doing this asynchronous programming. And I just love it.
So if you were to go with Michael's client-server thing, that server component,
yeah,
then the server component could just throw a message onto this channel and it would then appear in your, so you decouple, this is your decoupling
yep.
between the front end and whatever. Right.
It's just you only need an actual server if you're going to record stuff.
Sure, but I'm just thinking, so you've got this kind of reactive thing, but it's also your decoupling mechanism.
Yeah, absolutely, absolutely. And I think the RX, reactive streams, all of that is slightly different to what's here, but this is a really lovely Rust piece. And the D way of doing it's not quite as nice. It's much lower level. It's better than the C++ way of doing it, and I'd hate to do this in C.
I think that if there is any people in the room, this has now come into JavaScript as of June this year.
Was that ECMAScript 8?
ES 2018 with the
Right.
async generators.
Yeah.
I think you did.
Yeah. Python's also trying to do it. JavaScript's trying to do it, but at the end of the day, JavaScript and Python are single-threaded. And so underneath, it is so much easier.
Yes, oh yeah. But I think you can do this in Python. I think the code would look, there'd be some awaits in there.
If you were to ask Rob Smallshire, he would then blow up and say that async IO is a crock of effluent, and I'm putting words in his mouth, but
I think it would look I think, but
Yeah.
you'd have some awaits in there somewhere. But
Yeah. And I think there's an abstraction coming out here in all the languages,
Mhm.
which is very similar and iterating towards something that is very usable and a really, because human beings nowadays are actually quite good at writing single-threaded code. The problem is always concurrency and parallelism, and getting the right abstraction for those is really what it's about. And this one has actually convinced me that I'm going to go with Rust. So I really actually do quite like it. So that's sort of it. One little postscript is these are about digital video broadcasting, which, as with streaming, nobody gives a toss about anymore, except me, maybe. But what about audio, radio? So what's missing from GStreamer is actually a DAB and DAB Plus source. And so I think for my next project, because you can now write elements in Rust, you don't have to use C now to extend GStreamer via the plugins. Core, yes. The plugins that are there, yes. New plugins can all be written in Rust. And so I sort of mumbled to myself about doing a DAB Plus source. And then I realized that the standard is about yay thick, because everything is done not according to the standard, because there is no standard. DVB, yay thick, you know what you're doing. DAB, yay thick, because nobody knows what's going on. Well, the Germans do, because almost all DAB and DAB Plus activity in the world happens in Germany, because they're allowed to transmit 5 watts of DAB without a license or something. And so there are huge numbers of people with, it's like pirate radio all over again. And you're thinking, that's great, but it's all happening in Germany. And there's some really quite nice DAB players. I've got a pure one at home that's really nice, but that doesn't run on a computer. You have to actually physically buy it.
More portable than your TV though, right? So you could just bring it over to you.
Well, there are some versions of this that can be DAB players. I failed to bring it, but there's a company called Newelec that do versions of these with specific chips in that you can actually turn into radios rather than televisions. There's a layer, SOAPy SDR, software-defined radio, that is a middle layer that gets you between the hardware and a reasonable API for actually getting at the signals. So my plot is to use SOAPy SDR as a middleware layer and do some stuff like that. However, that's the pitch. I didn't have anything to sell, did I? I'm supposed to be X at everything. But never mind. So what I've tried to do is just sort of give a story, a bit of history, but along the way talk about some of the things I picked up on in a more general sense rather than specifically to do with the MythTV. And it comes down to be honest, D is way better than C++, just full stop end. Manually generated bindings are bad. Getting your bindings generated automatically is good. Rust is actually really quite a nice language, but you do have to get a little bit into the functional mindset. The C++ has now got option. D hasn't really gone that route in the same way. But C++, it'll take another 20 years for it to come to terms with option and result. But until they fix not being able to trim a string in a standard library function and have a standard queue for multi-threading, it's a non-starter in life, it really is. So I shall stop there and leave it at that.
Thank you, Russell.